The Egyptian pyramids. They are the only wonder of the ancient world still standing. Around 2630 BCE, pharaohs were buried in mastabas, flat-roofed tombs, but the project grew and the first pyramid was built. In the centuries to come, many pyramids would be created. Though much is unknown about how they were built, researchers have come up with some extremely plausible explanations for the creation of the pyramids. Firstly, it was necessary to transport goods from the ports in the Nile River to the building sites. The pyramids were built with over 1 million limestone blocks, each of them weighing about 2.3 metric tons. A painting dating back to 1900 BCE illustrates a huge statue being pulled on a sled by over 170 men. A person is seen standing in front of the sled and pouring water over the sand. According to Newton's first law, an object at rest stays at rest, and an object in motion stays in motion. If the men don't pull at the sled with the blocks, the sled will not move. Newton's second law of motion states that the net force acting on an object is equal to the mass times the acceleration. In this case, the two forces acting on the object in the x direction are the friction of the sand on the ground and the men pulling the sled. If the direction the men are pulling is considered the positive direction, the friction force will be counteracting the force of the men. If the friction is diminished, then the overall net force will increase. Since the mass stays the same, this means that the acceleration of the sled with the blocks of limestone will also increase. Daniel Bohn, a professor from the University of Amsterdam, conducted an experiment to show the act of pouring water on the sand, but only in small amounts, would reduce the kinetic friction, as the sand would be packed together to form a smoother surface, as shown in the picture. Newton's third law, in the most simple terms, says that every action has an equal and opposite reaction. The sled is pushing down on the ground, and the ground uses that same force to push back up. Due to the weight force of the sled and the normal force of the ground canceling each other out, the sled has no change in the y direction. The next step is to tackle how to get the blocks up these extremely tall pyramids. Many theories have said that one long ramp was used to get these blocks into place, but the most supported one so far is the idea of a spiral ramp going around inside the pyramid. This ramp will get steeper as it gets higher. The physics of this is a little different compared to just moving the blocks on a flat surface. Due to the angle surface, the net force in the direction of the ramp will include the x component of weight force, the friction force, and the force of the men pulling the blocks up, or I guess the tension force. At first, the angle will not be too big, so the force of the x component won't be very big. As Newton's second law states, net force is equal to mass times acceleration. As the angle increases, the x component increases, causing the net force to diminish and the acceleration to get smaller. The people pulling the stones up would need to increase the tension force by pulling harder to keep the acceleration consistent. Due to the angle of the ramp, the normal force will be parallel to the ramp, while weight force will still be parallel to the ground. In this case, Newton's third law is still in effect. The amount of force the block does on the ramp is the same amount that the ramp does on the block. The forces that are equal to each other are not the normal force and the weight force, however. They are the normal force and the y component of the weight force. Even though the force balance looks different from when the blocks are being pulled on a flat surface, Newton's third law still ensures that the blocks stay on the ramp and have no change in the y direction. This was my video about the physics behind the creation of the Egyptian pyramids. Here are my citations, and thank you for watching.